Good morning, everybody. Lovely day again today. Nice and sunny out there. If you can give me a green check in Blackboard, please. Make sure we're working properly this morning, and then we will get going. I want to continue on from where we left off, plug in our way through the learning guide. There's a few questions that I wanted to go through just to make sure you guys were aware of how to do them. We should talk about the course. I put some dates in. Thanks for those checks, guys. I put some dates in the course to kind of keep you guys on track as we continue on. Let's maybe go through that first. So last day was the 26th. I uploaded the video. If you weren't here, you can have a look through that. Like I said before, some of this stuff is kind of out of order, so it makes things a little tricky, but we should be good up to about, I don't know, somewhere between lesson 3 and 4 for right now. The dates I put in for the quizzes are 28th for the first 2 quizzes, so you should have those done now. I think I went in this morning and only one person had tried those. And again, the quizzes aren't, I mean, they count for 10% of your grade. Yeah, 10% of your grade. So you'll have a ton of quizzes. It's not like they're going to have a big impact on your mark. So don't be like really stressed out about the quizzes. And I mean, you always want to try to do your best, but you know, it's an indication whether you know the material or you don't. So I can look at it and see that you know, and you can look at it and see that you know. So there you go. 2 quizzes were supposed to be done by today, and then the next 2 quizzes will be done by the 29th. So I was hoping you'd have them done by the end of the day tomorrow. So everybody's a bit behind now. And then I was hoping that you would get the learning guide in on Friday, and I would get that password out to you guys, and then the test would be completed by the following Monday. So I want to kind of wrap this unit up by Monday. We still have lots of time, but obviously there's some work to be done here. So there you go. That's what I want to kind of accomplish today. Before we do that, I have a riddle for you guys, and I would like it very much if you guys could solve this. What I'm going to do is, I guess we should first establish some rules about this riddle. So a farmer's trying to cross a river, and he's taking with him a rabbit, carrots, and a fox. Some of you have probably seen this riddle before. I guess it's not a riddle. We'll call it a question to give it some meaning. So here's my river. I guess we should probably draw a boat. Boat. And yeah, the farmer wants to get from one side to another. There's the farmer. There's a bunny rabbit. There's a carrot. How do I draw a fox? There's my fox. All right. He can only bring one item at a time. The idea here is if he brings the fox with him and he leaves the rabbit alone with the carrot, the rabbit's going to eat the carrot, then he won't have any carrots. If he leaves the fox alone with the rabbit, you run into some problems because the fox is going to eat the rabbit, which isn't a good thing. And then same thing on the other side. So if the farmer is there, you can assume that nothing's going to happen. The rabbit will behave and not eat the carrot. But if the farmer leaves on the boat, then bad things can happen. So how does the farmer get all 3 things across to the other side? That's a good question, Mr. Borden. You're right. So what I'm going to do is I'm going to put you guys into some groups here. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go groups 3. There you go. So in Blackboard, you're all in groups of 3. You can type in those groups, and you and your group of 3 need to figure out how to get each thing across the river. Does anybody have any questions before we set you free in your river crossing adventure? Questions? Anyone? Questions? Going once, going twice. All right, well, I'll give you, I don't know, maybe like 5 minutes? 5 minutes. 5 minutes to see if you can figure out how to get each one of these things across the river. Nobody has any questions, so I guess you guys are just going to have to go for it. I'll pop into each of the rooms and see how things are going along the way, but you and your group need to figure out how to do this. So good luck. 5 minutes starting now. All right. I love the discussion. It's like, well, I would do this. This is perfect. And then somebody's like, well, then the rabbit's going to eat the carrot. And you're like, ah, man, why does this have to happen? What I'm going to do is attempt to, there we go. Everyone's back in the main room now, so you're no longer in little breakout rooms. Did any group, I didn't have time to look at all of the groups because when I kind of flip back and forth, I can't see what you've written before. So did any group figure out what the correct solution was that they want to share with everyone else? One interesting thing to note is that riddles always have some sort of trick, right? It's not like you can just, you know, it's not like it's just some logical way. There's always some sort of trick to get it. If the river was shallow, I like it. Thinking outside the box, and that's kind of how you need to get through these. Christina thinks she has it, so maybe Christina, do you want to just give me a couple steps on how to get everything to the other side of the river? And then we'll maybe see if Eric's group agreed or disagreed with you, Christina. So if you wanted to give, for an example, the thing you'd take across first, and then what you do next, give me a couple kind of steps along the way, and we'll see how we do. I mean, everyone could put their group solution in all at the same time, I suppose. There's nothing saying that we can't all put them in. So if we bring the rabbit across first, that does sound confusing. Okay, let me see if I got this right, Christina. So you take the rabbit across, and then you bring the carrots. But you can only bring one thing at a time. So farmer takes wolf, wolf takes bunny, but the farmer's the only one who can row the boat. I want to get back to what Christina said, because I think Christina, you have to take the rabbit across first because the fox won't eat the carrots. I'm with you there. Rabbit, carrot, bring the rabbit back, fox, rabbit. Okay, let's think about it this way. I'm gonna go with my little diagram here. So if we took the, I probably could select these things and actually physically move them. So everyone says take the rabbit across first. So the rabbit goes to the other side. Oh, I just took the rabbit's face. That's good enough. I was so excited about moving that. All right, so the rabbit's across. The fox isn't going to eat the rabbit or the carrot, so we're okay there. And then Christine says, bring the carrots. Okay, so the farmer is over here with the rabbit. Everything's good, and then the farmer goes back. And then if you take the carrots now, bring the carrots, but then take the rabbit back over to the other side. All right, so if I take the carrots with me now, let's see if I can take the carrot, the whole carrot. This is just never going to work. Oh yeah, I did it. All right, so we got the carrot over there now. So the farmer's with the carrot and the rabbit, that works. But then take the rabbit back. Okay, so the farmer and the rabbit go back. Farmer, the bunny, rabbit. What is next? Follow the other side with the fox, then take the fox, and then the rabbit last, yeah. So if I take the fox now, it's my farmer, I have my fox, and then the rabbit last. You guys got it. So, well done, Christina. Had you seen that one before? Had anyone seen that before? I mean, it's not obviously a new riddle that I came up with. It's kind of an old one. But the trick, there's always a trick. you have to, Eric had seen it before, of course. You have to take one thing over, and then you got to bring the rabbit back. All right, all right. Smarty Pants, Christina and Jesse and Eric had all seen it before. I'm going to dig up a riddle that you guys haven't seen, maybe for next day. You did a science project a couple of years ago. How did you do a science project on that? What, like scientific method? I'm not sure what a project would look like involving that. Like logic? I don't know. Interesting. All right. Let's get back. We had a weird science class. Oh, okay. All science classes can get weird sometimes. All right, so last day we were looking at the Unit 2 Learning Guide, and I asked you guys to download this, and I'd circled a bunch of questions and asked you guys to kind of work through them. Before I get too far into what I want to cover today, did anybody have any questions about any of these problems? Anything you encountered that you didn't maybe understand, or you got lost, or maybe got the wrong answer, if you tried any of these at all? Is there anything you want me to go through? I'll go through a few of them for sure today, but I mean, my main goal is just to make sure everybody's kind of on the same page going through these questions and you kind of understand what's going on. So usually the easiest way to ask a question is put in a page number. So you can say like 5 and then, you know, page 5, letter E or something like that. And then I could find it real quick. I don't see anyone feverishly typing, so I'm going to assume that nobody did any work. No, I'll assume everyone did the work and everyone got all the questions right. You guys are amazing at doing these questions. That's the assumption I'm making here. I'm going with it. You can't tell me otherwise. I think you guys could probably do F on your own. Page 6D. Excellent. That's what I like. Page 6. Letter D, A, B, C, D. All right. Let's see. That's 6. 6. Okay. I like it. I wanted to do letter B, but this is a very similar question, but it's just a little bit more difficult. So I'll do this one instead. So this is page 6. This is letter D. You'll notice that I don't have the formula sheet queued up here. I'm sure I could find it somewhere. I wonder if it's in here, this intro. Conversions maybe? No. All right, scratch that. On your formula sheet, you have the formula for a square-based pyramid. But you'll notice that this question has a triangular based for your pyramid. So it's not the same as the one up above. Obviously, these are different looking things. So it's a little bit different. You can't just kind of use the formula off the sheet. But if you put some kind of thought into it, you can kind of figure out what it is. So it asks you to find the surface area, if I'm not mistaken. I should probably confirm that. Yeah, number 2, find the surface area. And it asks you here to draw a net. So if you recall from, I forget what grade you learned about nets, a net is just an image that kind of, if you imagine taking some scissors and cutting along the edges and kind of unfolding this shape, what is it going to look like? So I'm going to have this black triangle on the bottom, and then let's maybe make this front triangle red. I guess I didn't really draw that the right way. Let's try this. All right, so there's the base. If I cut along the edges, I'd end up with a red triangle there. Let's make this left side, it's not the color I was hoping for. Let's make this left side blue. So that's going to look something like that. And we'll make this kind of the back that's farthest away from us, the back side green. All right, so if I cut it open, I would have these 3 triangles for my 3 faces, and then I'd have the base, which is the black one. And then I could put in some information here. I know that it's kind of hard to figure it all out, but each one of these is 6, the bases of all those triangles. And then it tells me that I have this, I said this front was the red one, tells me that the height of this from there to there is going to be 10. All right, I think that should be probably enough information to go with for a bit here. Because all of these base pieces are the same, these are all 6, then I can assume that the height of all of these is going to be 10. That's a fair assumption. So what is the one piece of information I do not have? If I wanted to find the surface area of the blue triangle, the green triangle, and the red triangle, I have base times height divided by 2 for each of those. That shouldn't be a problem. So I have the area of the blue one plus the area of the red one plus the area of the green one. And then I have this black base. Can I find the area of that black base triangle? What do I need to do to find the area? Maybe I'll just draw that one triangle by itself. It's not bad, I guess. So I know that each of these sides is 6. Do I have enough information to find out how to find the area of that? I have the perimeter, essentially. What do I have to do to get the area? What's the one thing I need to do? And you'll notice almost all of these triangular pyramid questions have this one common thing, one kind of trick. Nobody has any idea of how to do that? Gosh, got a long ways to go if nobody can figure that one out. All right, well, you guys think about it. I will find the area of the rest of these fellas here. It turns out these are all going to be the same, so I can just multiply it by 3. So let's take the area of the blue one while you guys chime in. Are they all the same size? That's a good question, Eric. No, they're not all the same size. The 3 faces are the same size, so the green, the blue, and the red. But the bottom is not the same size. It may be, but we don't know that. We don't have that information for sure. So anytime I want to find the area of a triangle, I'm going to go base times height divided by 2. If I'm looking at specifically the blue one, the base is looking like 6. The height is 10. And 6 times 10 is 60 divided by 2 is going to be 30. Everything's being measured in centimeters squared. So that's good for the blue, the green, and the red. Those are all going to be 30. But this black, the bottom, the base. What 2 things do I need to find the area of a triangle? I need the base and the height. I have the base, it's given, but I do not have the height. Is there a way I can find the height? That's a good question, Mr. Borden. You're right, class, it is a good question. If I have this height and I drop down, it is going to split this bottom into equal lengths. So if the whole bottom is 6, each part is going to be 3. So if I'm just focusing on this triangle here, can redraw it. It has a right angle in it. The base is 3 and the edge is 6. A right angle triangle, I know two things. It is the Pythagorean theorem, which is a squared plus b squared is c squared. Remember, the longest side of the hypotenuse has to go into the C spot. Everything else is a free-for-all. It does not matter. All right, so let's just call this h, this height, because I don't know what it is. So I'm going to go, according to my Pythagorean theorem, I'm going to go h squared plus 3 squared is equal to 6 squared. H squared plus 9 is equal to 36. Then I'm going to subtract 9 from both sides, so 36 minus 9. I'm trying to get h by itself. Uh, 36 minus 9 is 27. And then finally, I want to figure out what just h is, so I'm going to take the square root of both sides. So the square root of 27 is going to be 5.19. We'll call it 5.2. So there we go. The height of that triangle is 5.2. Now I have enough information to find the area of that black triangle. So we'll call it the area of the black triangle is base times height divided by 2. I know the entire base had a length of 6 because all of them have a length of 6. The height of that I just calculated to be 5.2. And then I'll divide that by 2. So 6 times 5.2 is 31.2, and then I'm going to divide by 2, so I'm going to get 15.6. All right, let's go back up here for a second. I know that each one of these triangles on the side are all 30, because they're all the same. This is 30, this guy is 30, and this guy here, 30. And then the bottom, I just calculated to be 15.6 centimeters squared. So all I need to do is add those up. 30, 30, 30 is 30, 60, 90. And then 15.6 plus 90 is 105.6. So the surface area is going to be 30. I guess I can include some units here. 30 centimeters squared plus 30 centimeters squared. Everywhere I go, I run out of room. Surface area, 30 centimeters squared plus 30 centimeters squared plus 30 centimeters squared plus 15.6 centimeters squared. What did I say that was? 30, 60, 90, 105.6 centimeters squared. Whew. You'll find that nearly every single pyramid question, they're going to give you either the slant height or the height. So I'll just leave this up for a second just in case you guys are working through it. But this question, they gave us the slant height, the side to the base. See the question above, they gave us the height of the triangle from the center to the middle of the bottom, which is different than from the the apex here to the middle of the edge. So for nearly every square-based pyramid or pyramid question, you're going to have to use the Pythagorean theorem to figure out a missing piece of information. Nearly everyone. I'm going to just go ahead and say everyone. Very rarely will you be given both the slant height and the height. If you're given both those things, then you won't know the length of the base or something like that. Leads, did that help you, or did it just make you a little bit more confused? Perfect. Thank you, Leads. All right, so I was going to do B, but since we just did that, maybe I'll just mention what makes letter B a little bit different. So answer meters if a square pyramid has a base of 4 by 4 and a height of 6. So it's the exact same type of question. It's saying the base is 4 by 4, so it's a square. So all of these are the same length. And it gives us a height. So a height is from the middle to the center of the bottom. So that is 6 meters. So this is a little bit different than the question we just did, because the question we just did, we had the slant height. So from the top to the edge. So this is the slant height. And we don't have the slant height in this question, so you're going to have to calculate it. So what you're going to do is just make a little triangle. So I'm going to just draw it. So we know that this piece was 6. I know that this is the slant height is what I'm trying to find. And then if I draw on a black line on the bottom, just to kind of complete my triangle here, I know that this is going to be 2 because this whole base is 4. So if I go halfway, it's going to be 2. So you'll find that every question with these pyramids, they're all going to have this common Pythagorean theorem type step in it. It's not just going to be as easy as calculating the area of 3 or 4 triangles and a base. Of course, the base here is a square, 4 by 4, so that's really easy. But you're going to have to use the Pythagorean theorem in order to find the slant height. Once you find the slant height, you know the height of the 4 pyramid faces around the outside. So that's the trick there. I'll let you guys figure out B and C. Did I want to do E? It's kind of a really, really hard question, E. I suppose I should do it just so we're all on the same page. All right. I said there's a trick, and I gave you this formula, and I said the area of the base is 1/2 times the perimeter multiplied by A. And A was this magical value called the apothem. And in this question, the apothem is measured from the centimeter to the middle of the side, making kind of a right angle. That's what the apothem is. It's a really fancy way of finding the area of a shape that isn't something that we would normally have the area of in our head. So if we were asked to find the area of a triangle, base times height divided by 2, a rectangle, length times width, a square is just going to be length times length. But in this case, we have 1, 2, 3, 4, 5, 6, what's that? Pentagon, heptagon, hexagon. Get my shapes right. Finding the area of that, we don't have that formula memorized. So anytime we have an irregular shape that has like 5 sides, 6 sides, anything more than a rectangle or a square, this formula will find you the area of the bottom. So they don't come up a lot, but they do come up from time to time. So what do we have here? It's how many sides do we have? We have 1, 2, 3, 4, 6. So 6 sides. So that means we're going to have 6 triangles. They're going to be really kind of skinny, tall triangles. We're going to have 6 of them. Now in the question it says the height. And the height is being measured from the apex to the middle of the bottom. And that height has nothing to do with the triangles, but it kind of does. So I'm going to redraw this. From the apex to the bottom, I'll call that my blue line. It's kind of like that line. And then I have this apothem, which is this red line. And then I will take the side down here as my green line. So I don't know what the height of these triangle faces are. I'm not sure what that height is. But I can find it because I have this triangle I've just kind of done a poor job of drawing here. I know this red line has a length of 4.3 because that's given in the question. I know the blue line is 22. And I'm trying to find this green line because it turns out that the green line is the same as the height of my triangle. So in order to find the area of my 6 triangle faces, I know that the base of each of these is 5. That's given right here in the question. It says the base edges are 5. So I know that, but I don't know the height along the face or the height of my triangle. So let's find the area of each of the triangles first, which is going to be base times height divided by 2. I've established that I know the base is 5, but I don't know the height. I'm going to have to use the Pythagorean theorem to find the height. So I'm going to go a squared plus b squared is equal to c squared. 4.3 squared plus 22 squared is equal to c squared. This is going to find me the height of that triangle so I can plug it in. So 4.3 squared plus 22 squared is 502.5. And take the square root of that. Take square root of both sides, and I end up with the height of that triangle being 22.4. So now I can use this information to find the area of each of the faces. So 5 times 22 divided by 2 is 56. Why did I write 50 then? 56.04. We'll just call it 56. And that is the area of one of them. How many triangles do we have? We have 6 triangles. So we're going to need to multiply that by 6. So 336.24, we'll just call it 336. All right, so we have the area of all of the faces. All of the faces have a combined area of 336 centimeters squared, which still leaves the bottom, the base. See if I can fit it in over on the left side. I said that this fancy formula for the area of the base was the perimeter, 1/2 times the perimeter times the apothem, which is from the center to the edge, meeting at a 90-degree angle. 1/2, the perimeter is 5, 10, 15, 20, 25, 30. And the apothem was given as 4.3. The one problem with this formula is that it does not show up on your formula sheet, which is kind of strange because you'd think it would, but it doesn't. So it turns out the area of the base is 64.5. So if I want to find the total area, I need to take the 6 triangles and I need to add the base. Pardon me. I said the 6 triangles were 336. The area of the base was 64.5. So that gives me 400.5 centimeters squared. Whew. No magical way to do these. You just need to break it down into the shapes. So if you have a bunch of triangle faces, figure it out. The only kind of trick to this question was the area of the base, because figuring out the area of the base was definitely tricky. If you didn't remember this magic formula that doesn't show up on your formula sheet, what you could do is this, and this is the way I did it last year. If I look at the base, I can break it down into a bunch of triangles if I really want. You're going to have so you have 1, 2, 3, 4, 5, 6 triangles, and you know the base of each triangle is 5 and the height is 4.3. So you could have figured it out that way as well. That was just it turns out to be the exact same process as this. But if you'd forgotten the formula, then you could have broken it up into these nice little triangles. So that's that. I'm going to keep going. I didn't ask you to do F. How about number 3? Just out of curiosity, you guys want to try number 3? I have a feeling you guys can probably do it, but I don't know if you've encountered something like this before. So basically what number 3 is asking is, instead of giving you the edge lengths of a cube and asking you to find the volume, it says, the surface area. It says the surface area is 121.5, and it asks you to find the length of each side. So if I have a cube, it says cube, so I know that I have my my sides are all the same length, L, L, and L. I know that the surface area is 121.5. And I'm asked to find the side length. What do we think? Can we do that? Is it possible? Is it impossible? How are we going to do it? Is there a way to do it? Is there a formula we can use? Is there a trick? What do we think? Any ideas? Any ideas? Not a single idea. Well, this isn't going to be good when you guys encounter this question on your test and you just sit there and stare at it. How could we start to figure it out? What could we begin with? Just move on to the next question. Take a 0. Divide by 6. That's logical. We have a cube, 6 sides. I kind of like where you're going with that. So, all right. How do I figure out what the surface area of a cube is? So I don't want that. I want this. Surface area cube. All right, I have a side. Let's just find the area of one side. Essentially, I'm going to have 6 times the length times the length. This L times L is going to give me the area of a square. I have 6 squares to make up a cube, so 6 times L times L. I could rewrite that as 6 times L squared if I really wanted to. Anything wrong with that? Nope. All right. The surface area I've already said. I said this is 121.5. So 121.5 is equal to 6 times the length of one side squared. Now Eric has said divide by 6, and he was exactly right. What I'm going to try to do is I'm going to try to isolate this L using some algebra, getting it by itself. Now, this suggestion of dividing by 6, you were just one step ahead of me. If I divide this side by 6 to get rid of the 6, I'm going to have to divide this side by 6 as well. So what Eric, I think, if I can peer into his brain, was doing was deciding to find, if you divided it by 6, that would give you a square. So he was taking it from a 3-dimensional sort of problem into a 2-dimensional problem. So if I divide everything by 6, I get 20.25 is equal to L squared. So it tells me that the side, one side, has an area of 20.25. But I'm not interested in the area of one side. I want to know just how one length of one side was, not the surface area of a side. So instead of taking L, I'm going to continue to kind of work backwards. I don't want to figure out what L squared was. I want to take the square root of it to figure out what L was. So if I take the square root of 20.25, I end up with 4.5 being equal to the length of one side. This is a quick way to check to make sure that we didn't make any mistakes there. We can kind of think of this surface area formula that we started with, and we said it was 6 times L squared. I can put in the 4.5, square it, and then multiply it by 6, and see if I end up with 121.5. So I can work backwards, figure out if that length was actually the right length. So you'll see a bunch of questions like this. All you need to do is take the surface area formula and then just work your way backwards using algebra, doing the opposite. If I'm dividing by 6, I'm going to multiply by 6. If I'm multiplying by 6, I'm going to divide by 6. Trying to get that variable, the length, by itself. It'll always kind of follow the same sort of process. All right, question number 5. I think you probably can be, maybe I'll just draw a picture. So question 5 says we're making cans, and the cans have a label on the side. Here's my beautiful can. They're planning on producing 200,000 cans, and they all have a height of 20, which is this side, and the radius is 5. If the labels cover the entire curved surface, how many square meters of material will be required to label all the cans? This question's silly on a few levels. Basically, if I took some scissors and cut down the side, I'd end up with this blue rectangle that makes up my cylinder. And I know the height is 20. I need to know the kind of the width. The other trick you're going to encounter in this question is notice that everything's given in centimeters. This is 20 centimeters. This is 5 centimeters. And then the question asks for square meters of material. So it's kind of an evil, entirely cruel question, because you're going to go through it, you're going to figure out the area of one label, you're going to multiply it by 200,000 to figure out how many or how much material you need for 200,000 cans. You're going to get an answer, and then you're going to check it, and it's going to be wrong, because your answer will be in centimeters squared, but the question's asking specifically for meters squared. So for number 5, be very, very careful. But I'm confident you guys can work through that. I didn't do this question with you guys, did I? This is number 6. I think this is from last year. Get rid of all that. Number 6 is really similar to the question we just did. Basically, these questions have this one thing in common, and that is that they would like you to not rely solely on a formula to figure out the surface area for these shapes. So the previous question was a cylinder as a can. This question's a cone. Now, if you use your formula sheet, you go to the surface area section, surface area of a cone, you'll see that the formula looks like this, pi r squared plus pi r s. Now, if I read the question really carefully, I have this pile, and I want a tarp to cover the outside of it. Does it say a tarp? Plastic. Yeah, so you need a plastic cover for the cone. Now, in this question, if I found the surface area of a cone, what am I actually finding the surface area? Well, I'm finding the surface area of the sides of the cone, the lateral area, plus the circle on the bottom. But if I'm covering a pile of topsoil, I don't need to cover the bottom because the bottom's touching the ground. So when I look at the formula, it's really important that I know what's in this formula, and I'm not just simply looking at a formula and then plugging numbers into it. So this first part, pi r squared, this is the circle on the bottom. But I don't really care about it. So when I'm finding the surface area, I can just ignore this. This pi r s is called the lateral area. And that is what I'm concerned about. So I have a feeling you'll probably need the slant height to figure that out. So you're going to have to use the Pythagorean theorem, but you should definitely give that a try for next day. Volume of right prisms, cones, and pyramids. We haven't done a lot of volume stuff yet, so I will maybe do a few of these. Now, as I kind of left you guys, this is page 8. I was giving you kind of hints as to how to do these questions. I asked you to do letter B here, and then I kind of just left you with this blue triangle. This is the base. I'll make it red now. And you're thinking, Mr. Borden, that's not the base. Isn't the bottom the base? I mean, this looks kind of like the front, is it not? Well, that's kind of the issue we run into when we're finding the volume of these shapes. Now, if I go to my formula sheet, a general right prism, to find the volume of a general right prism, all it says on my formula sheet is general pyramid. Yes, general pyramid. It says 1/3 times the area of the base times the height. That's the formula I get. That's it. It doesn't say how to find the area of the base, and it doesn't say what the base is. So that's all you're given. You need to kind of know what to do with that. So here's the problem. When I am taking the volume of a general pyramid, like I am now, what I want to do is I always want to think of this as being the height. So it doesn't make sense, and I can draw this picture, I can rotate this shape in space however I want it. The height is always going to be the side that connects the two faces of your shape. So what makes this special? Well, I have this triangular face here, so I know that I have this kind of pyramid type deal, but you imagine just cutting this edge along the top and just stretching it out or shrinking it in. I could make this back piece kind of come in if I wanted. It would be the same sort of shape, but if I drew it there, it would just be a little bit smaller. So this is what you want to call the height. If I look at the next question, it's the same thing. Again, I have a triangle here, and I'm saying this face is the base. Why is it important this is the base? Well, again, this is the shape which defines what I'm looking at. If I was looking at this red shape here, I would say, oh, that's a rectangular prism. It's just a rectangle. But no, it's not a rectangle. I have this triangular face. And again, this needs to be the height from here to here. If you can imagine, I kind of extended this out a little further. That's still the height. I could extend it out a little further. That's more height. It doesn't really change the shape. It just makes it bigger or smaller. But I can't do that if I think of this face as being the base, or this bottom square being the face that I'm concerned about at the base. So when you're doing these questions, it's really important that the base is always the shape that kind of defines what you're looking at, and the height is what joins the two similarly shaped faces. So in this case, I have this triangle. So let's do this question here. Volume. It's going to be 1/3. In this case, the base is a triangle. So I'm going to have base times height divided by 2. And then I'm going to have another height. So we need to be very careful because these aren't the same thing. So we should probably change one of these h's to something else so we don't get confused. If I'm just trying to take the area of my base here, the area of this triangle, base times height divided by 2 makes sense. And I could do this in 2 steps if I wanted to not get confused. I could say, okay, we'll find out what that area is, and then I'll multiply it by what I'm calling the height from here to here, or 30. So let's maybe do that in 2 steps. The base of my triangle, again, this ridiculousness that this learning guide has, this is 4.3 yards. Oh no, everything else is in feet. 15 feet, 30 feet, then I end up with this thing in yards. So what I need to do is take another step backwards. 4.3 yards times something converts yards into feet. Or I could convert my feet into yards. Doesn't really matter. Let's go to my conversions. It says that 1 yard is 3 feet. So 1 yard is 3 feet. So 4.3 times 3 is going to be 12.9. Is that right? That's right. All right, so let's go back to the area of my base. It's going to be area of a triangle. Base, I just calculated to be 12.9 times height, 15 divided by 2. $96.75. So what I'm going to do is I'm going to put that in here. I'm going to say, okay, the area of my base was 96.75. I'm going to multiply by 1/3 and then multiply it by the height to figure out what the volume was. How am I going to do this mathematically? Well, I'm going to take the 96.75, I'm going to multiply it by 30, and then I'm going to divide it by 3. You could multiply it by 1/3 if you wanted. Doesn't really matter. Now again, I've just calculated a volume in feet squared. The question says, hey, figure it out in yards squared. Gotta be kidding me. Everything's in feet in the question, except the one thing, and then I converted it to feet, and then, So there's another step. Just when you think you've got the right answer, you say, hey, great job. Now figure it out in yards squared. So what I need to do is take this 967.5 feet squared, and I need to convert it into yards. Now we just discussed that 1 yard was 3 feet. I'm converting units squared now instead of just linear units, so I need to square everything. So 967.5 feet squared times 1 yard squared, because 1 times 1 is 1. 3 times 3 is 9 feet squared. Feet squared cancels with feet squared. I'm left with yards squared. Just divide my answer by 9, and I end up with 107.5 yards squared. Holy guacamole, that was a lot of work. Notice what the next question looks like. Calculate the volume of this block of cheese in centimeters squared. Wouldn't it be nice if all the measurements were centimeters squared in the question? No. What have they done to us? Millimeters. Got to be careful. Got to be very careful. The remainder here is volume of those couple shapes. There's a couple word problems, and then I'm confident that you guys, surface area and volumes of spheres is super duper easy peasy. And that's kind of it. So we only have a few questions remaining. I was going to hope I had finished a little bit more than I did today. So what I'm going to do is I'm going to back up the test a little bit. I'm going to let you guys finish off this learning guide over the weekend because what's today? Today's Wednesday, and I won't see you again until probably Monday or Tuesday. So I'm going to back everything up in the course a little bit because I want you guys to have one more day at this stuff, one more chance to ask questions before you write the test on it. So what I'm going to do is I'm going to leave the dates for the quizzes. I'm going to leave these. So you should be done the first 2 quizzes by today. They should have been done already, but they aren't. And then the next 2 quizzes should be done by tomorrow, the end of the day tomorrow. We'll call that Friday now. Your learning guide, like there's really no reason you shouldn't be able to get your learning guide in before the weekend, but if you want the weekend to finish off your learning guide and then submit it on our next class, I haven't got the next week's schedule from Mrs. Wood yet, so I don't even know what that looks like. I wonder if it's up yet. October? No, just September. All right, so we don't have the next week's schedule up yet. So we're going to back everything up a day. I'm going to let you guys continue to work on your learning guide, come with questions next day, and then when you guys are done the learning guide, you can submit it, but it won't be until probably Monday next week. I'll give you guys the password for the test, and then you can write the test mid next week. So does anybody have any problems with that? Questions, concerns, anything you're unsure of? I'm going to finish just a few minutes early today. I'll go over a few more questions next day on surface area and volume of pyramids and spheres. We'll do some of those word problems because they can get tricky. But I will kind of hope that you will have gone through all of the learning guide next day and just have a few questions for me. I don't want to spend a ton of time on this stuff next day. We do need to get moving a little bit. So I'm going to leave you guys with that. Nobody had any questions, so that's okay. Mr. Ross, we have English next, is that right? Yeah, perfect. So you guys will have to stick around. You guys have English after this. You'll have to close out of my Blackboard room and then sign into Mrs. Ward's Blackboard room. As well, the live feed, you've done this already, but just reminding because some of you still are just sort of finding your way, a little different than the grade 9 program last year. The Blackboard, you'll have to get into Mrs. Ward's Blackboard, and then you'll have to close the live feed, wait for the English live feed to come up in probably about 10 minutes or so, and you'll have to click on that. So I believe she's scheduled to be on at about 10:20 to 10:30 in there. So be ready at 10:20, gives you guys about 5-10 minutes to take a breather. If you have any questions, you run into problems with the learning guide, let me know. I'll answer remaining questions, go over a few volume ones next day, and that's it. Hope you guys have a great weekend. I won't see you for a while. So you guys do need to get those quizzes done. That's kind of the main goal. Get the quizzes done, come with some questions next day, and we'll see you guys later. Have a great one. Bye-bye.